Yeah, welcome back everybody. Without wasting much time, let's just dive into what we have today. Following with the question Mr. Jones asked, the comment he dropped. So I want to answer the question with this video. This video is specially made for Mr. Jones. I'm so happy that you dropped that comment. Like, I'm so happy, and I'm very much excited to be doing this video for you right now, and I hope that it benefits everybody that is also maybe have the similar question to ask, but I'm not getting the opportunity to ask it. So what we have is DC and AC wire sizing. That's how to size your DC and your AC wiring. So because of time, I've just putting out all this because I don't want the video to take too long. So this is the formula for the calculation, this particular one here. That's voltage drop index, which is VDI. So I will be using this VDI. So voltage drop index, which is equal to amperage times, that's the amps you want to carry with the wire. That's how many amps you want the wire to carry, multiply by the length of the wire, that's the feet. The length is going to be in feet. So all over percentage voltage drop times the voltage. I just put this array voltage because it's solar, I want to use it to calculate, but this is actually for voltage. You can use it to do your AC sizing too, and your DC sizing too. So it's not only for solar array. I just put this solar array voltage because it's solar I want to use it for. Where the percentage in voltage drop is not, it must be less than 3. It must be less than 3. So it's either you use 2 or you use 1. That should be on your own discretion, anyone you want to use. But for me, and with what I've learned, because I've been doing so many research concerning this video, this is the best I've gotten so far. So I will be using 2 for DC calculation and then 1 for AC calculation, so that it will not I think this is going to give us a perfect answer. So I will be using 2 for DC wiring and 1 for AC wiring. So coming to this place now, this is just a table I saw online. I saw these two, this VDI and AGW. So I have to convert, I have to use my millimeter square, because most wires here in Nigeria, we don't use this AWG. What we use is a millimeter square. So that's why I have to bring it out in millimeter square, so that it will be easy for me. It will be more easier for me. So without wasting much of our time, so according to the question Mr. Jones asked, he was saying that he wanted to use an SPF model 300 TL. This is for the low voltage, which is 24 volts, and this is for the high voltage, which is 24 volts, because I actually went in researching about this grow watt inverter. So because he was saying you want to use something like 8 panels or 450 watts for this. So that's why I got into research to be sure that this inverter will be able to carry as much as those panels. So with my findings, I have a 24 volts here. That's a nominal voltage of 24 volts, which the maximum PV power it can take is 2000 watts. It cannot take more than 2000 watts. It's not even advisable you give it that 2000 watts. So here is the battery voltage, which the first one here, which is 24p, is 24 volts, and this 48p, which is 48 volts. So the maximum power for 24p is 2000 watts, while for 48 volts is 4500 watts. So the PV volts, that's the voltage range, is starting from 30 volts, that's 30 VDC, to 115 VDC, while for 48 volts you have 60 VDC to 115 VDC. So this cannot this, if you give it a lower voltage, it's not going to charge, and if you give it a higher voltage, it might damage the inverter. Same thing as this. So, and the maximum PV volt it can carry is 145 volts, so it can't take more than 145 volts for the both side. So I want to use this 24 volts for this calculation. So if what you have, that's I'm talking to Mr. Jones now, or anybody that is having the similar question. So if you buy your inverter, you have to check the label, you have to check the body to know, check the template, the name template, all these things will be written there. Whether it's 24 volt or 48 volt, everything will be there. So for you to know the parameters you are going to use. So for this, I'm going to use that same 450 watts you asked, but in this case now we are not using 8. What we are using is 4, because the inverter, which is 24 volts VDC, cannot take more than 2000 watts. You can use a lesser wattage so that maybe you can get like up to 1900, but I'm not advising you to go to that 2000 because of damage, so that you not damage the inverter. So from here, I'm using Felicity Solar. So from the research I did, Felicity Solar 450 watts has the power of 450 watts, then maximum power voltage, that's the maximum voltage it can carry, it will produce out is 40 volts. This is not the open circuit voltage, please. I am not using open circuit voltage for this calculation. This is the maximum. Open circuit voltage is the voltage the panel produces on no load, when nothing is connected to it, when it's just idle. But this maximum power voltage is when it's connected to a charge controller. So this is the highest voltage it can bring out, which is 40 volts, and the highest amperage too is 11.25. This is not the short circuit amperage. I think the short circuit amperage is 11.9, and the open circuit voltage is 47 volts, but that's not what we are using in this calculation. So then I just put this thing out because I have to use Google. 15 meters because of the feet that we'll be using later. So 15 meters was mostly when we do solar installation, we don't use more than 15 meters except the distance is so long. That's why I'm using 15 meters. So 15 meters, when you convert it to feet, you have 49.2 feet. So I am going to pause the video to write down the parameters, then we'll continue. So because what we are using is 450 watts, so the the maximum amperage two of them can take is 80 amps. So the charge controller is 80 amps. So with this, going with a connection of 2 series. So if you have not watched our video concerning solar panel calculation and the rest, maybe I will leave it in the description below. The reason why I did not talk about batteries, because I've done that video before. So if you are confused, maybe you should rewatch the video. That's why I don't want to go back to battery calculation or battery sizing, because I think we covered it in the video you left that comment. So maybe you should check back. I just went straight to DC and AC wire sizing. So using this, we are using 450 watts. So the connection we are going to use, because of our maximum PV volts, we cannot go more than 145 volts. But clearly stated that the PV power volt should be 115. So what we have here is 40 volts. To be on the safer side, we are going to use 2 series for this calculation. 2 series, that's connecting 2 panels in series like this. That's positive to negative, leaving you with one big giant positive and one big giant negative. So doing this connection, the voltage is going to add, which is 40 plus 40, giving us 80. while the amperage remains the same, which is 11.25. Then when you have this is just 2 panels. When you have another 2 panels, then you parallel the 2 of them, connecting positive to positive and negative to negative. Voltage will remain 80 volts, while the amperage is going to be 11.25 multiplied by 2, because voltage is constant while amperage will increase, because we are doing parallel. We've covered this thing in our last video, which I will leave the link in the description, so I just want to do it a bit fast. So with this, what we have here now is VDI is amperage, which our amperage should be 11.2 divided by that multiplied by 2, because what we are doing is 2 series and the 2 circuits in parallel, giving us a double amperage, which will be 11.25 multiplied by 2. I want to use my calculator and do it fast. 11.25 times 2 will give us 25.5. So the amperage here is 25.5. The next thing is the feet, which I've already given us a value here. So if you are using more than 15 meters, you can also check it. You can convert the meters to feet, so that it will be easier for you to calculate, which is 49.2 all over. Our voltage, because what we are calculating is DC, that's our voltage drop. We are using 2 multiplied by the array voltage, that's the solar array voltage, because the first one we did is series, which we add the voltage of the panels, which is 80, because it's 40-40. But during the parallel, the voltage remains constant, it still remains 80 while the amperage increase, so we have 80 here. So going with this, multiplied by 49.2, giving us 1107 over 2 times will be 160. So 1107 divided by 160, we'll have 6.9. So VDI is equal to 6.92. That's almost 7. Coming to our chart that I stated earlier, with what we have here is 1, 2, 3, 5. We did not have 6 and we did not have 7. So once you get any value that is not here, you just round it up to the next one, which is 8. So what we have is 6.92, which is 8 here, because there is no 6, there is no 7. So the nearest number there is 8. So 8 in AWG is still 8, but in millimeter square is 10 mm, as we normally call it. So what you will use for this is 10 mm DC cable. I saw plenty videos on YouTube where they will tell you, or where you see where they say when calculating for copper wire, that's when using copper wire you do times 1.1, and when using aluminum wire you do times 1.7. I did the whole calculation. I did 2 of them. I did this one, I did that one. I was just looking for the best one, but I think I prefer this. Just that when going for a solar installation, use original copper wires. When you want to buy your wires, use original copper wires. If you want to use aluminum, maybe that's when this calculation that you will multiply with this and multiply with this, that's when it's going to come in. But if you are not using a copper, if you are not using an aluminum wire, I think this is just the best. If your distance is more than 15 meters, this value might be higher. So you have to be specific with the distance because of voltage drop and the rest. Yeah, so this is basically how you calculate the one that's from panel to your charge controller. You will use 10 mm. So let's now calculate from charge controller to battery. You have to bear this in mind. Here we just used the amperage direct, the current direct. But in this case, we don't even know the value of the current passing through the wire. That's from your charge controller to the battery. So we have to first of all find the current that will pass through the wire before we substitute it in our equation. So knowing that I is equals to P power over voltage. So the power here, the maximum power here we have is 1800 watts. 1800 watts over voltage, your battery voltage, which is 24 volts, because what we are using is 24p. So power 1008, that's the maximum power that the panel can produce, divided by the battery voltage where the power is going to, which is 24 volts. So let's do that. 1800 divided by 24, giving us 75. So our current here is 75 amps. So because the wire going from our battery to our charge controller is usually not that lengthy, so I used 2 meters here, and 2 meters is equal to 6.56 feet. So this one I just used Google, I just typed it on Google and the thing came out, so you can also do that. So VDI will give us, substituting this to our formula, we have current which is 75 amps multiplied by our length, which is 6.56, all over 2. Remember, when using DC, when calculating for DC, you use 2, divided by our voltage, which is the battery voltage, because this time around what we are calculating is voltage from, what we are calculating is the wire from charge controller to the battery, which will give us, let's do this really fast, I don't want the video to be too long, 75 multiplied by 6.56, giving us 492 over 24, which is 48, divided by 48, giving us 10.25. So 10.25 going to our chart. There is no 10, there is no 11. What we have here is 12. So approximating it to the nearest whole number, which is 12, we have 6 AWG and then 16 millimeter square, that's 16 mm. So this one, this 10 mm is the one that will carry the panels to your charge controller, while you will use 10 mm to carry the charges to the battery. Wait till they worry me. 16 mm, sorry. Don't mind me. 16 mm, because what we have here is 10.25. So here we have 12, we have 20, we have 32. So 12 is our nearest whole number, which gives us 6 AWG. This is just the same, all of them is the same thing. I'm just interpreting it in the language that all of us can understand. Because me, if you say 6 gauge, I might get confused. But if you tell me 16 mm, yes, that is the language I understand. That's why I have to approximate all of them. So that this table now, you can also write this table down so that it will help you in your own calculations too. Yeah, so these ones that we just did is for the DC. This one is the one that will carry the panel from the rooftop down to your charge controller. This 16 mm will carry it from your charge controller to your battery. Then the next one now is we are calculating for AC. That's the one you will put the where you connect your ACs. That's your input and output connections, the wire gauging you are going to use. So just as we did before, we are going to find the current first, which is power over V. The power in this case now will be the power of the inverter, which is 3000 watts. 3000 watts over the voltage. You can use 220, you can use 230. In my case, I'm using 230 volts. So using 3000 divided by 230, 3000 divided by 230 will give us 13.04. 13.04. Sorry, I'm making this video in the night. So when we substitute, VDI will give us 13.04 amps multiplied by the length. We will still use this 15 meters. So the more the length, the more the wire. So if you are going less, like 10 meters, or you are going 5 meters, the wire might be more shorter, like the gauge might be smaller. So but for the purpose of this calculation, we are using 15 meters, which is 14.2 feet, 49.2 feet, 0.2 all over, all divided by 1. Remember, when calculating for DC, you use 2. That's for your voltage drop. So but when calculating for AC, you use 1. So that's why I'm using 1 here multiplied by the voltage, which is 230 volts. So using this, we'll have this, our answer is still here already, equal to divided by 230. This is wrong. 13.04 multiplied by 49.2, giving us 641 points, just approximately 6 all over 230. Let's just use the 641.6 divided by 230, giving us 2.8. Going to our data chart, we did not have 2.5 or 2.8. What we have is 1, 2, and 3. Since we have surpassed 2, the next whole number, 2.8, if we should approximate this, is 3. So 3, if you are using AWG, you will use 12. If you are using millimeter square, you will use 4. So for your AC connections, you will use 4 mm. Okay, so from our calculation, from solar panel to your charge controller, you have 10 mm. From your charge controller to your battery, you have 16 mm. From AC, your AC wire is 4 mm. Then like I said before, that you might be doing your own research and you will come across this type where they say DC in millimeter square will give you VDI multiplied by 1.1 for copper wire, multiplied by 1.7 for aluminum wire. So I just want us to do something really fast so that you will see that anyone you use is the same thing. Math is math everywhere. So what we have here in our, let's use when calculating for the solar wire to charge controller, what we have here is 6.92. So let's use that 6.92. VDI is 6.92 multiplied by 1.1, giving us 7.6. And here I've just written out the sizes of wire we have. We have 1 mm, we have 1 mm, we have 1.5, we have 2.5, we have 4 mm, we have 6 mm, and so on. So here we're having 6.7, and here we're having 7.6 on my. Here we have 6, there is no 7, there is no 8, there is no 9, all we have is 10 mm. So it has already passed 6, so the nearest one we are having is 10 mm, which is still the same thing we got, 10 mm. So still doing the same thing for this one, we have 10.25. If you still do that, 10.25 multiplied by 1.1, you have 11.2. And here after 10, what we have is 16 mm. So we are still in the same place. The only difference now is when you are using a aluminium wire instead of copper wire. Let's check for the first one. When you are using aluminium wire, this 6.92 multiplied by 1.7, giving you 11.6. So have you just seen the difference? Instead of using a 10 mm copper wire for this one, you will use a 16 mm aluminium wire. So you have to be guided. Then another thing I want us to do, but this one I want you to try it on your own so that I will be sure you are following. From battery to inverter, I want you to try this one, knowing that because we first of all calculate for the current is equals to P over V, and the power we have here is 3000 watts over 24 volts. So I just want you to pause the video and do it really quickly before I will show you the answer so that I'll be sure that you are following me. So let's continue. We have 3000 divided by 24 volts, that's the nominal 24 volts, that's the nominal voltage of the inverter. We'll have 1, 2, 5. So our VDI will give us 20. This is our current, 125 multiplied by the feet. We'll still use the 3 feet. We'll still use the 2 feet, which is 6.56. 6.56 all over. We are still using DC, that's why we are using 2 multiplied by the voltage, which is 24, giving us multiplied by 6.56. we have 820 over 48 volts divided by 48. We have 17.0. We have 17.08. Okay, without looking at the VDI chart, we can easily do this using the second way of doing it. We have 17.08 multiplied by 1.1, because we are using a copper wire, not aluminium. So we have 18.7. We have 18.788. So the nearest whole number here for 18.788 is 25 mm. So for your battery, inverter to battery, from battery to inverter, what you have is 25 mm. So if you got 25 mm, that means you are on the right track. So still using our VDI chart, what we have is 17.08. 17.08. There is no 17, there is no, the nearest one is 20, giving us 4 HW and 25 mm. So any way you do it, you are on the right track. So Mr. Jones, I hope I've answered your question, and thank you for using this question to actually bring my notice to this. Was I was actually planning to do this AC and DC wiring sizing, but with this, I think we have covered everything we need to do. So if what you have is 3000 watts, that's 3000 TL, the high voltage 48p, so you have to know, put all your parameters in place so that you will be able to get a correct answer. The reason why we used 2 in series is because of our maximum voltage of PV is 115. So if we say let's connect the whole 4 in series, giving us 40 times 4, we have already exceeded the maximum power. It's going to burn our charge controller. So if we say let's use 1 let's just do 1 connection, that's all the whole 4 in series, all the whole 4 in parallel, giving us about 40 amps, more than 40 amps. But the voltage here, because it's 40 volts, the input voltage is from 30. So you can also do that connecting all in parallel. So if you are connecting all in parallel, that means you will be having a more higher gauge because you are carrying a very high amperage. So it's always better for you to do series instead of parallel, because the more the amperage, the more the gauge. So it's just for you to know what you want to use, what you want to achieve, exactly what you want to achieve. Then you know the suitable way for you to achieve it. That's reducing cost, reducing time, and reducing energy. For you to know that all this is just dependent on the distance you are going. So I want us just to use 1 meter for this DC from battery to inverter. I want us to use 1 meter, and 1 meter will give us, that's this divided by 2 will give us 3 points. It should be about 3.28 feet. So using 3.82 feet, let's just do this for you to see that all depends on your distance. Depending on the distance you are going with the wire, VDI will give us 125 multiplied by 3.28 over 48. Let's just go fast. So 125 multiplied by 3.28 will give us 410 over 48 volts. 410 divided by 48, giving us 8.5. So 8.5 here, the nearest is 10 mm. So it all depends on the distance. So if you are going to a smaller distance, you use 10 mm. If you are going to a longer distance, the wire gauge is going to be increasing because of the voltage drop. So you have just to make your distance as short as anything, so that you will minimize your cost and minimize your energy and minimize your time. So hope this video is helpful, and then if you like this video, please give me a thumbs up. If you have not subscribed to the YouTube channel, please do me a favor, I'm begging, subscribe to the YouTube channel and click the bell button so that you'll be the first to know whenever we post a new video. And thank you so much. And Mr. Jones, thank you so much. I really appreciate this. So Thanks for your time and have a great day.